Hi everyone. So it's the end of Spawnfest 2021, and I wanted to show you all what I've been working on for this hackathon. So the tool I created is called eFlambè, and it's a tool for rapidly generating flame graphs of Erlang and Elixir code. So if you've ever generated a flame graph of Erlang or Elixir code in the past, you've probably used a tool called eFlame. And it's an excellent tool, but it actually takes quite a while to get to a point to where you have a flame graph that you can view. It's typically a multi-step process, and it can be quite cumbersome to get the tool installed and get the flame graphs rendered. So I thought maybe just to demonstrate how easy it is to generate flame graphs with this new tool, I might just do a quick demo here. So I was looking around at some of the other competitors for this year's hackathon, and I noticed this project called Sketch, which is a pretty cool project, pretty cool example art they have here in the README. And I noticed they had a Barnsley fern. So I thought this might be a cool little project to try out the flame graph generation capabilities of this new tool on. So I'm just going to go ahead and clone down this project. Oops. I'll fetch the dependencies. And then the only thing we really have to do to get started with eFlambè is to just add it as a dependency. So we'll just open the mix file here. Add it as a dependency. All right. Now let's hop into the IEX shell. Let's take a look at the command that is going to generate this fern. So it looks like it's examples, Barnsley fern, and then they used an argument of 7,000. So I may actually have that already saved in my history here. And I do. So yeah, so this is the one command that you need to run in order to generate a flame graph of this particular function. So the first argument is a tuple containing the module name, function name, and then the arguments for that function. And then the second argument is just a list of options for eFlambè when it generates the flame graph. So in this case, I'm not going to customize it much. There's several different options. You can look in the README. But the one I am going to use is the open option, which tells it to go ahead and open the flame graph that it generates in the program I've specified. And I've got SpeedScope installed. I like it, so we'll have it open in that one. So I can just run this. It'll run that Barnsley fern function, and then it will automatically open the resulting flame graph. All right, so here is the flame graph. You can see there are quite a few function calls here. There's a lot going on, so we might just want to zoom in. But immediately we can get an idea of what is happening here. So there's some high-level functions that take quite a while to execute. The biggest one being add fern points, and then enum reduce range increment. We can also see that over here there's some interesting stuff going on. There's a sleep that occurs, and then it's actually calling a random function, and that random function actually takes a while here. So let's drill into this. And you can just double click on that. And so we actually get an interesting observation here that this random function, which I'm not familiar with, takes significantly longer to return than pretty much any of the other functions that were invoked by this Barnsley Fern function that we executed. So almost immediately we've kind of learned something about the performance of this particular function that we've just called. So anyway, I thought this might just be a good way to see how powerful this tool can be. Let's just for fun run the same function again with a different argument to see how it affects the performance characteristics of the function. So maybe I'll just run it with an argument of 10. I'm assuming this is like the number of iterations that this function goes through to generate the fern. So immediately you can see we've got a new flame graph opened, and obviously it looks quite different. It appears there's much fewer function calls, and it just seems much simpler overall. So it does appear to be some sort of recursive loop inside this reduce range inc function. So anyway, I hope this gives you an idea of some of the power of eFlambè, and hopefully it will be useful to you all in your Erlang and Elixir projects. This is a new project, but I do plan on maintaining it for the future, so if you have any feedback, definitely let me know. Thank you.